Unit 8, Chapter 1, Solar Storms. In 1859, an amateur astronomer named Richard Carrington claimed the stairs to his private observatory near London. He adjusted his telescope and projected an image of the sun onto a screen. He was looking at sunspot areas of the sun that appear darker because they are slightly cooler than the surrounding areas. Suddenly, two patches of white light appeared around one sunspot before dawn the next day. Spectacular display of red, green, and purple light, known as auroras, lit up the skies as far south of Panama in Central America. In the eastern United States, people were able to read newspaper outside in the middle of the night. Further west in the Rocky Mountains, the light composed campus enough to get up and start cooking breakfast. Some people even thought their city had caught fire. What Carrington had observed was a solar superstorm, a massive eruption on the surface of the sun sent billions of tons of electrical and magnetic matter hurtling through space. It even caused damage here on Earth when the matter collided with our planet. Magnetic field is caused electrical currents to surge through telegraph lines, disrupting communication. No solar superstorm as powerful as the 1859 event has occurred since. That's why scientists find in difficult to calculate the impact a similar storm might have on today more wired world. A hint came in 1989 when a solar storm, a force less powerful than the Carrington event, caused 6 million people in Canada to lose power. A Carrington-class storm could leave millions without light, drinking water, sewage, treatment, heating, air, air condition, air conditioning, fuel and telephone service for months. Few objects seem as familiar as the sun. There is up in the sky every sunny day. Yet few objects are so strange. Look through a solar telescope, and the sun is transformed streams of light the size of planets rise into black space, only to come back down hours or days later, as if controlled by some unseen force. Neither solid, liquid, or gas. The sun is made up of plasma, the pure state of matter. Scientists and learning scientists are learning more about the sun and how solar storms form. The sun is packed with magnetic fields, some emerging on the surface as sunspot. They have to power the solar wind, sending a constant stream of particles out into the solar system. These fields can also become installed with plasma, forming gigantic blues that are illuminated by the hot, glowing plasma. When blues grows, they cause the enormous plasma eruption known as solar flares. Such flares release intense energy into space.